That is V1 minus VA over R1 plus. Here now we have V, this is V2 minus VA over R3 because the resistor here is R3 is equal to this I2. I2 is VA minus VB. VA minus VB. Our VB is 0 volts divided by R. Welcome to today's class, Nodal Analysis, Part 2. Okay, most of the examples. Here we are required to calculate the values of current I1, I2, and I3, okay, using nodal analysis. For the introduction and steps of solving nodal analysis, please check Part 1. Solution. We can call it as our VB. This VB is equal to Vref, the reference voltage, which is 0 volts. Okay, good. Now let's form the nodal equation. Nodal equation from KCL now. From KCL, that is Kirchhoff current law. You notice that this I1 plus this I3. I1 is incoming current. I3 is also incoming. Is equal to this I2 that's leaving. So I1 plus I3 will give us I2. Okay, will give us I2. I2 is leaving. I3 and I1 are coming. So, or you can still say I1 plus I3 minus I2 equals 0. They are still the same. Sigma of current at this node is equals to 0. Now, Ohm's law, we have that I is equal to V over R. But from here, you notice that this 6 volts is of higher potential to this particular nodal voltage. So what we are going to do while applying Ohm's law to this I1, we will have to substituting V1 is 6 volts. We have 6 minus VA over R1 is 5 ohms plus V2 is 3 volts minus VA over R3 is 4 ohms is equals to VA minus 0 divided by R2 is 3 ohms. Now let's simplify this circuit. Simplifying the circuit, we can still have 6 over 5 plus this 3 over 4, okay? Then minus VA over 5 minus VA over 4 is equal to 3 is equals to VA over 3. Good. Let's collect like terms. Collect like terms. Over 5 plus 3 over 4 is equal to, here we have VA over 3. So VA over 3, this minus VA over 5 and minus VA over 4 will cross to the equality sign. So we have plus VA over 5 plus VA over 4 because they were minus initially. Alright, now simplifying further, I can have 6 over 5 plus 3 over 4, that is 1.2 and 0.75. So we can have here 1.2 plus 0.75 is equal to VA, or bracket 1 over 3 plus 1 over 5 plus 1 over 4. This is same as VA, or bracket 0.33 plus 0.2 plus 0.25. Okay, here 1.2 plus 0.75 we have 1.95 equals VA over this. So that's 1.95 is equals to VA or bracket 0.33 plus 0.2 plus 0.75 will give us 0.783. We have 0.783. Good. Now divide through by 0.783 to find VA, which is the nodal voltage. So we have here 1.95 divided by 0.783 is equals to VA bracket 0.783 divided by 0.783. So this can cancel and then this can go. Therefore, VA is equals to 2.49. We can now say approximately 2.5 volts. Good. 2.5 volts. Now we can easily calculate I1, I2, and I3 to find I1, I2, and I3. Okay, so I1 here is equal to, remember, our I1, we have V1 minus VA over R1. So we have V1 minus VA over R1, which is our V1 here is 6 volts minus 2.5 divided by R1 is 5. This is equal to 3.5 divided by 5, which is 0.7 ampere. Okay, we have 0.7 ampere. Similarly, I2 will be VA over R2. So I2 is VA over R2. Since VB is 0 volts, the reference voltage, we are going to have here VA is 2.5 divided by 3 to 0.83 ampere. Secondly, I3 is equal to 3 volts minus 2.5 divided by R3 is 4 ohms. This is equals to 0.5 over 4 divided by 4 equals 0.125 ampere. Alright, so these are the values of I1, I2, and I3. Okay. From case here, I1 plus I3 equals I2. Remember, you can still like designate the current movement this way, and this way. Okay. That is, from this node, the current will move outside. From here, the current will flow outside, and from here, it will flow outside. Just sum everything and then equate it to 0. Then VA will subtract 6 volts because VA now is of higher potential to 6 volts if it is moving away. But because it's moving inside, this 6 volts is of higher potential. So 6 will subtract VA. In our next example, we are going to solve it. Okay.